unmanned aerial vehicle, an aircraft with no pilots on board. For joining us today to this webinar.
Компания AERONOVA создает линейку аппаратов разных классов, от легких беспилотных платформ до тяжелых дирижаблей для сложной логистики, на примере которых мы продемонстрируем их возможности и эффективность в современном мире. В линейку аппаратов будет входить несколько прототипов. Это NOVA 01 и Аэролет 01. Эти аппараты создавались специально для того, чтобы на них опробовать и применить в действии все те современные решения, которые компания планирует применять в своих будущих моделях. Рад вам представить нашего первенца. Это дирижабль NOVA 01. Фактически это динамическая копия нашей следующей модели дирижабля NOVA 2. На нем мы отрабатываем управление, систему автопилота, сбор данных. В будущем его модификация, уже доработанная, может быть как отдельный продукт, будь то мониторинг или реклама. Его размер составляет 130 кубических метров, длина 17 метров. Он может брать с собой на борт 20 килограмм полезной нагрузки, будь то какое-либо оборудование, либо любой перевозимый груз. Также будущие модификации этого аппарата могут стать отдельным коммерческим продуктом, где этот аппарат может стать платформой для рекламы, либо средством для мониторинга и наблюдения. Аэролет 01 – это наша гибридная версия с улучшенными аэродинамическими характеристиками. Это экспериментальная модель, на которой мы также отрабатываем новые решения, нестандартные для дирижаблей, но которые, возможно, будут применяться в следующих моделях. В нем помимо аэростатической подъемной силы будет работать еще и аэродинамика, которая улучшает его показатели в некоторых задачах, в которых могут быть применены дирижабли. Его объем практически 190 кубических метров, длина составляет 19 метров и грузоподъемность, которую он может брать с собой на борт, около 50 килограмм. Также в линейку аппарата будет входить дирижабль NOVA 2. Это дирижабль объемом 2000 кубических метров и способный перевозить 500 килограмм на 500 километров. Его пассажирская версия будет рассчитана на 6 человек, включая пилота. Следующий за ним дирижабль NOVA 8 объемом 8000 кубических метров. Этот аппарат уже способен будет перевозить 19 пассажиров, либо 4 тонны на 3000 километров. А завершает линейку аппаратов дирижабль NOVA 35. Это дирижабль уже совсем иного класса, который имеет жесткий корпус. Это будет первый и самый маленький аппарат с жестким корпусом, который компания планирует выпускать в будущем. Данный аппарат способен будет поднимать минимум 15 тонн и перевозить груз на 1000 километров. Данная линейка аппаратов будет закрывать достаточно большой объем потребностей, который сформировался сейчас на рынке логистики и грузоперевозок. А наш следующий шаг – это дирижабль NOVA 2, который способен перевозить 6 пассажиров, либо 500 килограмм на 500 километров. Всем спасибо, кто смотрел это видео. Друзья, оставайтесь с нами. Впереди будут новые ролики и выпуски того, как мы возрождаем дирижаблестроение. И увидимся в следующих роликах.
Hello everyone and welcome. Thank you for joining us today to this webinar. Today I'm going to talk about artificial intelligence for unmanned airships. How exactly a modern ship can replace a crew of 30 and makes airship operations cheaper, sustainable, and more safer. Before we diving into the technology exactly and with details, let me tell you a couple of words about myself to get to know about me more. So my name is Milad Ranaei, and software and AI engineer and lead software engineer at AERONOVA. For over a decade, I have built autopilot system, ground control stations, sensor fusion, and AI pipeline and architectures for unmanned aircraft, from small drones to complex autonomous platform. My focus has always been the same. How can software and AI replace manual work, make fly safer, and reduce the cost, which is a very important thing in the business. That is exactly what we do at AERONOVA with Airship. So yeah, you heard AERONOVA. So I'm going to tell you a couple of words about AERONOVA. AERONOVA company has been established in 2024 with only one goal, a specific goal, to bring back this forgotten but sustainable technology back to the sky. AERONOVA is an engineering and design company focused on modern and next generation lighter than air systems. Our core team include aerospace experts with over 40 years of experience on major programs such as Gulfstream, G650, G280, and Airbus A350. So we have around 65 engineers with a solid industrial base supported by leading institutes, the most famous institute in all around the world. We have already built and tested our first flying prototype, so I can claim that we are not only in theory. So our first version is already in the sky with the Nova 01. So now let's build the foundation. Starting with the most important word today, artificial intelligence. This is why we are here actually. So we want to talk about what is AI, why AI, and what is a UAV. So when I'm talking about AI, I'm talking mostly about artificial intelligence, the simple word AI. So what is an AI in the simple word? In simple word, AI is a software that can learn from data and make a decision without a human telling every single step, do what or do that. As you can see in the slides, mostly the traditional software follow the fixed rules. If this, then you must do that. So if, for example, airship see the trees, as you can see here, so then the airship must make a decision to go to the right side or go to the left side to not hit the trees. So AI goes further a little bit more. In fact, AI actually can find a pattern in data, adapt in new situations, and improve over time. It means that it's learning over time. So it's learning by the environment's data. For an airship, AI can decide how to fly, what to look on the ground, and how to avoid obstacles, and how to land smoothly. All gonna do by AI automatically, without any kind of human beings. So AI is a smart software, but why does an airship specifically need it? So that is exactly our question. I'm going to answer it. So there are three simple reasons why we are going to use AI inside the airship. First, cost. So, which is actually very important in the business, you know. So unmanned helicopters or airplanes need a pilot on every flight. Not only pilot, but also crew. So AI replaces much of that humans work with the software that runs 24 hours a day without getting tired, because this is machine, so it never gonna get tired. Second, safely. So maybe you ask this question of yourself, why it is safe, why AI is safer than the pilots or a lot of crew. So safely, AI can check thousands of the sensors every second, run safety checklists before every flight, so and react faster than any kind of human beings in many situations and circumstances. So, and the third, scale. One operator can watch one airship in the moment. So, but AI can help one operator manage many airships, plan routes, and process camera data from all of them at the same time. So, without AI, airships stay expensive to operate. So with AI, they become a real business tool. So this is why we are going to integrate AI to AERONOVA 01, which is the first version of the airship. To understand our solution, it's better to get know a little bit about some terminology, which is one of them actually is a UAV. So what is a UAV in the simple word? You will hear the word UAV today. UAV means unmanned aerial vehicles. So an aircraft with no pilots on board. So when we are talking about the pilots or when we are talking about the UAV, it means that there is no pilot, no crew on the airplane or on the board or on the airship or any kind of vehicles. So drones, for example, drones is a UAV, or airship is also included in the UAV, but much bigger, much slower, and it can stay in the air for much longer time, which is very significant points and make it a very big difference between the drone and between the airship. So a UAV is controlled by software on the ground and software on the board. So the software on the ground, which is called ground control station. Sensors send data up and commands go back down. AI sit exactly in the middle. It's read the sensors and decided what to do. As I already mentioned it, it's make a decision. So an airship is a special type of a UAV. It's lighter than air, yes. And as I said, it's used very little energy to stay up. That makes it perfect for longer monitoring missions and perfect for AI. So we have AI now, and we have UAV in another side. So now let's connect them to make it a big idea. Digitalization. So why digitalization is matter actually here? So because digitalization using software, data, and AI is the key to success for airship and any kind of airships. So an airship without a pilot controlled by smart software becomes much cheaper to operate and it becomes safer as well. So today I will show you where AI lives inside an airship system, what sensors it uses, and what becomes possible from gas detection to smooth autonomous landing. So let me show you a full roadmap of today's session here in this slide. So here's our plan. We will look at how exactly AI controls the airship and where AI is used on board, which sensors fit the AI, and how computer visions open a new monitoring missions. I'm going to explain to you everything with details in the further slides, so don't be worried about that. Then we will talk about obstacles avoidance and real-time path adjustments, aerial imagery, and AI assistant landing. So at the end, for sure, we will answer your all questions live. Okay, so here where AI is used in an airship. So this is actually very big questions, maybe from many of you. Let me show you a little bit a bigger picture first. So AI is not only one program. It's the many layers working together to make AI exactly usable in our platform or in our airship. So the layer one, which is the most critical and important layer, is the flight control. AI keeps the airship stable and follows the mission routes. So in any kind of vehicles, manned or unmanned, one of the most important things is control. So that flight control for the manned and unmanned, no matter, need someone to control the vehicles. So for example, the pilot's going to control the vehicles, airplanes, and for drones and airship, we need some like visual pilots to control it. But how exactly we are going to control it? This is exactly AI play a good, very significant role. AI keep exactly the airship to be stable on the air and follow the missions and follow the roads from one position to another position to going to the destination. The second layer is perception. So cameras and sensors let AI see the world. So like detecting pipes or gas leaks or obstacle and landing zones, detecting the landing zones, all gonna do by AI in the airship. So for sure, airship doesn't have like an air or ears to hear or eyes to watch for sure. So this is exactly why AI coming and playing the role. And in the third layer, decision making, AI choose the best path, adjust for wind, and replans when condition change. So you know that the airships is very, very light, lighter than air. So there's a helium gas inside the balloon. So the point is that here, the winds can has a very high impact to the direction of the airships. So this is why AI can choose the best path, adjust exactly that wind, and then replan when any kind of changing happen in any kind of condition happen on the earth. And the fourth layer is the ground intelligence. AI on the ground process aerial images, classify them and detect them, and exactly send it to the ground control stational operator what exactly the airship is observing, and send the result, final result to operator to make a best decision. So all these four layers work together, and that is what makes an unmanned airship useful in the real world. So we saw four layers, and let's zoom exactly into the first one, which is the most critical one, and how exactly AI can control the airships, or control the flight in somehow. So one of the normal aircraft, a human pilot does three important basically jobs: fly the aircraft or airplane or manned vehicles, navigate it, and watch the system, and monitoring and observing any kind of critical errors happened or not. In our airship, AI software gonna do all these three things. The pilot has exactly two specific layers. The inner loop, the autopilot system, has two specific layers. So basically, it's the inner loop, runs many times per second. It keeps the airship stable on the air, exactly like a balancing on a bicycle. The outer loop think about the mission. So go from this point to some specific points, fly exactly at this height, in which kind of high airship must fly, and follow these paths. So not going to the wrong path or illegal zone. So today the inner loop use a proven PID control. So the PID control is called the proportional integral derivative. So controlled is a feedback control mechanism widely used in industrial automation, so robotics and engineering. So it continuously calculates an error value as a difference between the desired targets and a measured process variable. So automatically adjust the system inputs to minimize that specific error. So it's safe and trusted for decades. On the top of this, modern AI add reinforcement learning algorithms that train in the simulator thousands of times before it even touch a real airship. So we are training somehow from the data, and AI is going to be more and more intelligence by time. So flight control needs data. So data, actually, I can say, is the most important things for any kind of unmanned vehicles. So how exactly we can get this data? This is a very big question, maybe very important questions in your mind, how we can get this data, and how exactly we can train our neural networks or AI to learn from this data. So the answer is a sensor. But which kind of sensor we are going to fit the AI? So here you can see different type of sensors. So as I mentioned already, the airships, let's getting know better about the sensors. The airships doesn't have ears and cannot hear or cannot see. So how they can contact with the environments, how we can collect this data from the environments. We are doing this by the sensors. So we have a different type of sensors which we are going to use in the airships to collect all of the data from the environments and try to using this data for training or AI for futures works. So AI, so basically our airship carried many sensors. The gyroscopes and accelerometer, for example, for direction of movement, GPS for detecting the position of the airship, barometers for altitude, just understanding the altitude, how exactly it's going up and how it can exactly land. The magnetometers, for example, for headings, wind sensors for weather, battery and motor sensors for energy health. So all these sensors you can see here, and plus extra sensors we are using to make the airship more intelligent and collecting the information, make a huge data set from this data to our training and for our AI system. So for example, for vision AI, we use cameras. So we have a different type of camera. In the future slide, I'm going to talk with details about this. We use cameras. optical cameras for images, for example, and optionally infrared cameras for heat detection, for example, gas leak or hotspot or on pipelines. All this data flows to the ground control software or ground control station. So we need some software or applications to give this opportunity to operators to see all the status of the airship in the real time or autopilot system in the real time. So which called ground control station, which at the end of this presentation I'm going to show you with details the ground control station which we have created in AERONOVA for our unmanned airship. So all this data flow through the ground control station or mission control on the ground. We are using the the open Mavlink protocol, which is called Mavlink, the same standard used across the drone industry, all drone industry. So many sensors give many answers. So maybe you ask this question from yourself: how does AI combine them into one trusted picture? So because we have a couple of sensors, as you can see here, and for sure we need to combine all this information and to AI learn from this information. So here this combined sensors we are calling this sensor fusion, as you can see here. One trusted answer is, here is an important idea: no single sensor is perfect. No single sensor is perfect. So GPS can lose signal, for example, or gyroscope can drift. Wind can push the airship, of course, because airship is very, very light. So AI does not trust one sensor alone. So it combines many sensors using the sensor fusion. This method exactly for to combining all of these sensors is called Kalman filter. I'm not here going to explain the details about this algorithm, but we are just combining them with the Kalman filter. Think of, just very shortly, to explain, to make it clear, think of it like a team of judge. For example, each sensor given opinion, the Kalman filter combines all the opinions into one best answer. So it's sometimes something looks wrong. If something looks wrong, the system flag it immediately, and the system understanding the problem and the issue. So the sensor data tell the airship, for example, where is it? Cameras tell what exactly it see on the ground from the airship, from the sky. That brings us exactly the computer vision. So probably many of you heard about the computer vision, and maybe the computer image classification or image detections. But computer vision is play a very, very important role in any kind of unmanned vehicles. So in these days. So now let's talk about a little bit one of the most powerful AI tools for airships, which we are going to use in the computer vision in these slides. So computer vision means AI can that understand images and videos, not just storing pictures, but actually seeing that what exactly inside the pictures. So we are human, we can observe our environments, we can see it, we can detect it, we can classify everything around us. So that is trees, or that is person, or that is car, that is vehicles. But it's very difficult actually for computer to just teach the computer to understanding exactly, to get to some feeling about the environments. That is why the cameras, actually the computer visions, coming and actually try to really fix a lot of complex problems in our lives. So in basically detections, when we are talking about the detection and classification in computer vision, and which we are going to use, and we are already using in our airships, detection means finding the objects mostly. So we want to find exactly the specific objects in the camera to, after detecting these objects, try to make best decisions, or try to do some acts after making the decisions, after detecting these objects. So, for example, we are going to detect the pipeline, or we are going to detect the buildings, specific buildings, vehicles, a person, a gas pumps. So as you can see here in the photos, in the presentation, Classification, but they're all related to detection. So after we are going to detect, we need to classify them, yes? So classification means naming what exactly was found. So this is pipe, or this is farmland, or this is, for example, damage. So here is about the detection and classification. For an airship flying slowly, the airship mostly flying very slow on the low altitude. So this is extremely valuable because the cameras actually can observe everything with more details and accurately. So the camera is seeing a large area around the airship because airship's not going very high, like high altitude like an airplane. So AI process every frame and highlighted what exactly the matter in these photos automatically without any kind of human beings touch it or highlight it and try to watch it on the screen. So everything going to do automatically by AI. This is how exactly we turn a flying into a smart monitoring platform. So basically, when we are talking about the camera, we are using inside the airship, we are not going to use camera only for example, detection, the obstacles around the objects, or we are going to actually using this camera for monitoring as well, which is in the future slide. I'm going to explain more about this. So let's about the monitoring. Yes, what exactly we can monitor with AI on the airship? This is a question many guys actually asking me. Why exactly must use airship to monitor? What exactly we can monitor with airships? So I can classify actually the monitoring stuff which we can detect inside with using the airship to detect by, for example, pipeline inspection. AI detect the corrosion, leaks, or construction near a pipeline roads. It's compare image over the time and flags change. So it's a very good and very accurate actually to using AI for pipeline inspection or gas detection, for example. Using optical or infrared cameras, AI can identify gas plumes or abnormal heat pattern that may indicate a leak. So this is also AI can be used very useful actually for gas detection as well. So environmental monitoring, AI classify land cover, so water quality indicators or vegetation, for example, heard from the aerial images. Infrastructure inspection, yes, power lines, for example, bridges, solar farms, wind turbines, AI find detect faster than manual review. So after we collect a huge amount of the data from all of these infrastructures, then we can exactly train on the specific points that cameras can detect and send it alert to the ground control station for detecting. So another actually sphere which AI can be, computer vision can be very good for monitoring is the border and security monitoring. So AI detect movements, mostly vehicles or unusual activity in exactly defining the area. So in the defined area, AI can detect which kind of, for example, movements happened, or for example, which kind of vehicles moves or unusual activities happened or not happened. So the airship stay in the air for a couple of hours, even days, or even months. So AI works the whole time the airship is flying. So that combination is very actually hard to match with the helicopter. So this is exactly one of the main important and I can say significant reason why airships is, I can say, much better than helicopters or manned vehicles, because they can stay on the air for a couple of days or a couple of months. So they can specifically monitor some specific region or area and keep eyes on them and try to detect and classify, as I explained already in this slide, a couple of things. So monitoring is one use. Another is buildings map and aerial imagery from above. So maybe you're asking, what is it? What is the aerial imagery? Airships are also excellent platform for aerial imagery and mapping. I'm going to explain to you what is it and a little bit further, but when we are talking about the aerial imagery, we are talking about scanning the area. So flying slowly, yes, airship flying very slow, and airship capture sharp. So overlapping photos of the ground, for example, AI stick exactly the images together into the map, so it can scan and generate a 3D map of the environments and land. So it's somehow try to scanning the environments, and this is one of the actually very I can say very shiny points which airships can be useful for scanning the environments, because it's not like a drone, for example, have a problem with the energy, or for example not stay very long on the air, so they can stay on the line very long on the air, and they can we can define exactly in the ground control station from which point to that point we want to monitor. So exactly the airship, after entering to the specific zone which we are setting and we are defining in the ground control stations, the cameras can automatically turn it on and try to scan the environments. So this exactly data support the agriculture mostly, which we are going to scan, for example, the lands or some specific area. This kind of data supports the agriculture, urban planning, and asset management mostly. So AI automate the whole pipeline: capture, process, classify, and report. So instead of sending a survey team, for example, to gather the information from that area or that land which is not accessible, probably many kind of area are not accessible by the humans, so we can just very easily try to send an airship. Instead of manual reviewing the thousands of photos, AI does it in 1 minute. So it can collect a lot of information from the specific area in the couple of seconds, try to process them, and try to make best decisions what exactly supposed to do. So flying over the area is also one thing. So flying safely around the obstacle is another thing, which probably many of you are also going to ask these questions. What about if we have some obstacles, for example, in front of the airship? What we are going to do in these situations? Yes, let's talk about it. Let's talk about this a little bit. So, how we can solve it? So, if we see, for example, airship is moving and some obstacles coming in front of the airship. So, obstacle avoidances is a critical AI task these days, and many scientists in all around the world exactly working on it. But not only in the airship, in drones and in autonomous vehicles. So airship moves very slow. Airship moves basically very slowly, yes. But they are very huge, so they cannot exactly turning quickly like a drone. So drones is a very small vehicles, and they can acting and they can change the directions very quickly. But airships not able to do it because they are huge and they are very slow. So AI use camera and sensor data to build a picture of the space around the airship. So it detects obstacles, trees, buildings, tower, or other aircrafts, for example, and calculate the safe path around them. So, and somehow machine learning models here play a role. So machine learning models mostly trained on the million and billion of example recognized obstacles faster and more reliable than rule-based system alone. So if a new obstacle appeared during the flight, for example, a crane at a construction site, yes, AI can replan the route in a real time without stopping the mission. So how exactly it's work? How exactly we are going to detect it, this kind of obstacles around the airships? We are using actually not only RGB camera, we are using the LiDAR camera, which make a point cloud from the environments around the airships, and we just using this point cloud to understanding which kind of obstacles are in front of the airship. So I'm going to explain to you a little bit further, but Now just know that avoiding this obstacle is a part of the bigger idea. Adjusting the path in real time is all the time. So real-time path adjustments, yes? What is a real-time path adjustments? This is very also important topics right now, very hot actually topics, and probably many state-of-the-art articles published, and a lot of scientists have been working on exactly this topic, how exactly we can in the real time adjust the path of the airship and change the direction of the airship. For example, wind changes, yes, and weather drifts or shifts. New no-fly zones appear. A fixed flight plan is not enough. So we cannot exactly come to the ground control stations for the unmanned vehicles and try to set the points and say exactly directly moving between this point to that point to reach to the destination. So we are not able to do it because winds can be changed, the weather can be changed. They're absolutely unpredictable. We cannot predict that, you know, or even if we are able to predict that, probably they are not so accurate. So AI enables real-time path adjustments. During the flight, the system constantly compares where the airship exactly is with where it should be. So we try to understanding, the AI actually try to understanding. And if we push the airship, for example, of course it's doing, then AI correct the path. Yes, because how I will a little bit further, I will come back to this to tell you exactly how. But for example, if the battery energy is lower than, for example, expected, then AI shorten the route or send the airship home safely. So, for example, airship is on the air, is moving, and suddenly, for example, the battery, I don't know, just try to, the battery energy actually is getting low. So the airship must exactly make the best decision where exactly must land, how can land, and this is why, again, AI just play a very important role to understanding exactly how we are going to change and in the real time try to adjust the path of the airship by the circumstances. So the path adjustment work actually in the air. Landing is the hardest moment of all. So we are going to change the path for sure if some situation happened or some situation occurred, for example. But what about landing if we are going to land the airship? Yes, which I can claim that this is one of the most difficult topics right now, how exactly we can smoothly land the airship to not going to damage the airship. Because as I told, airship, as I mentioned already, airship is very light. So the landing the airship has a lot of challenges because the wind again has an impact. For example, the detection cannot be exactly accurate, so we cannot exactly detect the environment probably in some kind of specific circumstances to land the airship exactly in the good point. So here I just prepared the slides which can show how exactly AI smoothly can land the airship. So landing the airship is one of the, actually as I told you, as one of the hardest topic, especially without the human pilots. So airships are sensitive, yes, to wind, as I said. So, and near ground turbulence, near exactly the ground is turbulence. So AI helps by using the vision and sensors to detect the landing zone exactly as I show you. You detect the landing zone. It try to measure wind speed and direction and adjust the descent rate and hitting exactly in the real time. So the AI landing control works like a careful pilot. Slow approach, small correction, soft touchdown. It can use visual markers on the ground or GPS with the high precision. So we tested every new landing behavior thousands of times in the simulation before it goes to the real ship. Safety first, no, always. So landing relies on the algorithm work together. So it is, as I told you, it's very complex task actually. Let me explain the three most important one, which is the PID, reinforcement learning, and wind control. So But I want to really, before trying to explain about this three important algorithm, which we are going to using actually in our, it is the base of our unmanned airship. I want to give you just one intuition about exactly this landing. So we are basically using here not only RGB camera, we are basically using the LiDAR camera as well. So the LiDAR camera, what is exactly the LiDAR camera is doing? The LiDAR camera try to make a point cloud from your environment. So it has a depth camera. So it has a depth inside the camera. So it tries to generate from this depth, give you a point cloud. And using this point cloud, we're understanding exactly how far, for example, the airship is from one specific object or from the land. So this is why we are not only using RGB camera, we are going also using the RGBT camera and LiDAR camera. So in the unmanned airship, the version AERONOVA 01, we are using more than 5 cameras around the airship to scan a very accurate environment around the airships. And we are exactly using this RGB D and the depth camera and LiDAR camera or LiDAR camera for detecting the calculated distance, detecting the land exactly, and with a very high advanced more algorithm in the AI or in the reinforcement algorithm, try to adjust the speed and direction of the airship to landing smoothly. So three most algorithm which we are going to use mostly in the airship is the PID, reinforcement learning, and the wind control. So let me explain the three important ideas actually that power our AI in the simple word. So first, what is a PID mostly? The PID means proportional integral derivative. I already just very shortly just mentioned that. This is a control method that has flown aircraft safely for decades and is still using in many manned and unmanned vehicles. Think of the thermostat, for example, in your home. The room is too cold, yes? The heater turned on, and after that it's too hot. So it's getting turned off. So when that, for example, thermostat, for example, the room, suppose your room is so cold, yes? Then the heater is turned on. When it is too hot, it's getting turned off automatically. So PID exactly works the same way, and but it's much faster than that, you know. So because it's very important exactly in time exactly is very important, very fast and accurately try to make a decision. So many times it's probably many times every second. So the airship is not where it should be, for example. Yes, the airship is not where it should be. PID calculate the error and send exactly the correction, more thrust, smaller rudder change, adjust pitch, small steps very fast, you know. All of these things gonna happen in the couple of seconds or even milliseconds. So this is the trust foundation of our flight control today. But it's not all. The most significant actually part which bring the AI exactly in this pipeline is a reinforcement learning algorithm, which we have developed our own specific reinforcement learning algorithm. We are trying or a specific architecture for that, and this is a type of AI that learns by trial and reward. So what I mean by that, imagine teaching a dog. Yes, you have a dog and trying to teaching the dog a new trick. So the dog tries something, yeah, it's trying to do something. So if it's good, you give a reward to the dog. So, and if like a treat, yes, and if it is wrong, no treat. Over many tries, yes, the dog learned the best behavior. So this is exactly the system which called trial and reward. So this is exactly the algorithm, the main algorithm which we are going to use in our airship autopilot system. So you know, the reinforcement learning work the same way, you know, but the dog now here is a software. So, and it trained inside a simulator. So we have a simulator, and we have 1,000, we are trying to using the simulator 1,000 of times before it over touch a real airships. We are collecting the data from the simulator. We are trying to using this algorithm for trial and reward to exactly understanding the best parameters for learning. So this kind of process is mostly called learning, you know, and mostly I can claim that in most of the unmanned air vehicles in the current days, they are using the reinforcement learning in the different kind of aspects. So, and the third, how AI control the wind. So this is also another maybe question when the airship, for example, going to smoothly lands. And an airship is, as I told, airship is a very large and very slow for sure. Wind pushes a lot, too much push the airships. And this is absolutely not like a helicopter or drones can sitting smoothly like helicopter or drones. So, or AI basically read the wind sensor on board, speed and direction many times per second. When wind somehow push the airship, of course, PID makes a small correction immediately. When wind is strong or changing the directions, reinforcement learning helps because it has already practiced, yes, on the similar wind situations, on the thousands and millions of data by the thousands of time in the simulator. So we trained over than right now 500 billion parameters and the data we collected from the simulator. We try to simulate the different kind of wind directions. From the different kind of direction we pass the wind to the airships, we try to collect the data and make a huge data set for it to exactly working on this sphere to get the good result. So the result, airship stay on pass, so hold altitude exactly and use it less energy for sitting and for landing. So even in difficult winds, it still has a lot of challenge. We are still not reaching exactly to good answer. For these questions, for smooth landings and wind. When we are talking about wind, when the airship is on board. Still a lot of open things for us, in the current moments. So I'm not going to claim that we 100% solve this problem, but we are strongly working on it to reach to the very good results. So at AERONOVA, we actually combined this PID, which I already explained, proven and safe, which is proven and safe and already use it, with reinforcement learning, adaptive and smart. It's make it system or airships very adaptive and very smart with PID and reinforcement learning. And always tested in the simulation before real flight. So before simulation, we are going to test all of these things for sure before the real flights on the simulation to test that everything's by AI. So that is the theory actually. Now let's look at a real proof, a little bit. Your airship Nova 01 is already flying, as you can see at the first of the presentation. You already see. So it's already flying. So it's already in the sky. We are right now training on the data. We are collecting right now a huge amount of data from the simulation, from the simulator, which we are using in the from the different kind of sensors. We are collecting all of these data, and our first version, which is the AERONOVA 01, it is the full stack of the production. We are it's already on the sky. We are right now integrating all this algorithm and step by step into the airships to make it the airships more safer and make it the airship more, I can say more with more accurate. So here, here I want actually to show you a very quickly or applications or ground control station basically, which we have developed here for last 2 years. So all I think and all I mentioned, all the algorithm sensors, what I have mentioned already, which we have set up already on our airships, somehow all this data must come to some ground control station, as I already mentioned it. So, and what is this ground control station? This is a software that give you ability to operators to see exactly what is happening inside the airship. So in any kind of autopilot system, not only airship is not only related to airship, for drones or any kind of autopilot system, you can use this ground control station. So we have developed, AERONOVA developed our own ground control stations for the last 2 years. And right now I can claim that our ground control station visually, if you're comparing with the other ground control station, the very complete ground control station, we are supporting the right now AI, integrating the AI into these ground control stations. And it has a couple of, many features already, so you can control the airships based on these ground control stations very easily. You can try to make a pass for the airship and tell to airship exactly in which kind of path airship must move. You can set the define for exactly for monitoring on the map to say to airship exactly after passing and entering to the exactly specific zone that your camera start to turn on and try to monitor the area. So as you can see here, I just try to make a one more operations here, just for a couple of try to loading. Yes, perfect. So here we can try to set exactly points. So I just try to create a new missions here. So I'm going to create a general mission for our airships. So and then here you are. So we create a new mission. So suppose we have a new airship and we want to move our airship exactly. And
again.
so, okay, so here in the ground control station, I'm going to show you exactly how we can define a path for the airship and how exactly the airship can move between the paths and from one point to another point to reach to the destination. So here easily in the ground control station, you can set a mission, and after that you can try to set a points exactly from which points your airship going to take off to, and in which point airship going to landing. So you're setting the point here, setting the mission path here. So I'm just defining the mission path exactly for the airships, and try to set exactly the airships from, for example, the first points. It will be the takeoff points, exactly airship in the takeoff points, in the which kind of altitude, which kind of, for example, the speed or heading, for example. We can set all the parameters here. Airship can fly. So I just trying, for example, to setting the path here. The first waypoint, it's called a waypoint, yeah. And in which point exactly the airship can landing, exactly, and the which point exactly the airships can be the home of the airships to fly. So, and after you setting all these points here, you can define exactly in which zone airships after entering can start to do monitoring. So you can define the zone here as you can see. So I'm just setting up here, set up the points here for the specific zone, or for example that zone can be the circle mode, or for example in the square mode from, for example, here to here, or for example in any kind of specific shape. For example, you want to set that airships try to do monitoring for you. So here I try to set up all of these things. You can set all the altitude, you can changing the altitude, in which point exactly the airship can change the altitude from going from that point to, for example, this point. For example, I put in this, for example, 50 meters just for testing, as you can see. So here you can see the points for altitude points, and very easily you can set up the mission. So you just set up this mission. The operator basically try to set up this mission. So that that route and adjustments, actually, which I have already mentioned, it will be done after the airship going to take off and try to moving between the waypoints. And here there are a couple of features inside the application which I'm not able to explain about everything, but our application is handling the multiple airships. So operator can handle multiple airships here inside the map. You can just enough to just activate the airships, select your airships, and you can see exactly how airship moving. So after you set up all the points, you can easily try to just upload the points here on the airship. So and then it shows you exactly the flight checklist, which I have already mentioned. So with the AI, we are going to check all the parameters inside the airships to like a GPS status, motor status, battery levels, vehicles connection, telemetry data, everything, arming status, home positions, and a couple of more exactly telemetry data we are going to check before starting to fly. So this is exactly doing also by AI. And after you checking everything, you can just send the comments and the airship start to fly. It can show you all the information telemetry. So and here also you can see all the telemetry data like a heading or pitch or altitude, heading, altitude. So you can set up which kind of telemetry data you can exactly see here in the application. So you can just select them and you can show you here. You can see the real-time pass, which and real-time notification here in from which point exactly the airship moving to second points, or I don't know, for example, if the mission, for example, changed by the AI, for example, if the winds, for example, came and try to has an impact, you can see all the missions information in this box. So and also you can activate your cameras around the airship. We are showing here the two important cameras, which using the AI, for example, for detecting exactly the objects. When the airship start to move, it detecting the cars, detecting the humans by the box. It's just trying to draw in the bounding box around the objects for the detection to just make a decision exactly what airship must do based on the objects. And next to it, after just airship start to move and everything set up, pass all the checklist and everything in the autopilot systems and operators, then you are able in the advanced monitoring panels, check the systems, check all the informations of the airships. So behind that, AI can absolutely fine tune every parameters here, try to send it exactly the parameter passing actually from the filter of the AI, so AI can make a decision which kind of exactly altitude is appropriate for this kind of conditions, whether to airship moves, and many parameters like a helium gas inside the balloon, how much exactly helium gas we have inside, what is the temperature exactly of the gas, and everything's coming to this monitoring system. So and in the case of, for example, changing the weather, just AI trying to understanding and alerting exactly how the airship exactly, how the weather is going to change. We have a forecast prediction also, which is also by using the AI to just predict it exactly the incoming weathers to understanding exactly how airship can fly in the safer position. So here you can compare it. Also, we are just right now, we are working on this. We have not done yet. We are implementing right now the algorithm for trying to comparing all the telemetry data. We are trying to saving all of the telemetry data, not only from the real airship which is flying, also from the simulator for our training. So we have already collected a huge amount of the data for our data set for training. And here, in the same time, you can see all of the telemetry also indicators here, such as, for example, the indicators for altitude, for speed indicators, for gyroscope indicators. You can see all the indicators here, how exactly the engine is working right now, has any error or not. If there is error in any kind of engine's parameters, here is showing that they are getting changing the color. Also the airships changing the color dynamically. So here absolutely dynamic everything's inside the airships getting changed the color inside the airships if the pressure coming down or up, if the temperature changing, or any kind of system error actually we have here. The changing the airships or changing for example the gondola, or for example changing any kind of fins, or if the fins not working, changing the color and immediately sending the alert not only to here but to other platform like for example to make the operators just inform actually the operators about this error as well. So and behind this actually setting up an AI right now, we are just improving right now, is trying to learning from the simulation. This is exactly the simulation data. We are trying to increasing the wind speed, try to saving this data for our futures for training the reinforcement learning algorithm and training and in some part actually we are using the supervised learning algorithm, which is manually try to train on the specific data. And after you set up everything, so we have a camera panel. You can set up the cameras, actually, what actually you can see in the camera panel. You can change the map. And moreover, we have added, this is for exactly that scan, which I have already mentioned inside the presentation. We have ability here to changing exactly the map from the 2D to 3D to see exactly how airship is moving, in which kind of altitude is moving, and which kind of obstacles actually airships face it with. So here we can change exactly the maps from the 2D to 3D exactly to see all the altitude points, and all of these maps going to be like a 3D after scanning. So it will be show the apartments, the height of the apartments, so that we can see exactly how airship moving between these 3D maps between these points. So you can monitor everything, and these monitorings which the operators can do here. Actually in the behind of these applications doing by AI as well. So all the things here, what I told you, they are not only theory, they are actually in the in the practice right now, but we are practicing right now, we are improving, developing them right now. We are not done yet. We have a lot of things to do because nobody cannot claim that 100% can achieve the accuracy in AI. So this is actually the very just short explanation about our ground control station. There are a couple of things here actually. The indicator page, you can see, for example, the flights monitors. You can see the settings. You can set up your maps, everything, the color for your maps. You can set up many other things here, which is out of time to explain everything here. Moreover, here we have also the NOVA 02, which is going to launch probably in a couple of months. So in the NOVA 02, we also we're supposed to apply all of this algorithm for the AI in the NOVA 02 to help the pilots to make a better decision. So it's this AI which we are integrating right now is not only belong to NOVA 01, it's also belong to NOVA 02 as well. So the NOVA 02 is already under the assemble, so we are working on it right now. So, and I hope very soon we can achieve a very significant result. So this is all what I just hear, all of this presentation, what I have mentioned it. Again, all the AI, all of these things which I have already demonstrated to you, they are not only, I can claim that they are not only basically in the theory parts. We are also in one of the algorithms, we supposed to publish a papers for that, for example, for that AI parts. So all these things actually on the action right now. And you can just, for more observation, I can say you can just later just check out our YouTube channel. Probably you can just observe it, all of the videos there to understanding better. So here I can just right now finish this presentation. Basically, I already just explained most of the important things about the AI, how we can integrate it. This AI. Thank you so much from all of you to listen to this presentation and webinar. And I hope probably we can build one strong AI platform and strong airships, modern digitalized airships with the help of each other. Thank you so much. Yes, there are a couple of questions here. I'm just trying to answering. Uh, Asking what is the gas inside the balloon. This is the gas inside the balloon is helium gas. This is why it's not flammable gas, and also it's somehow try to be lighter than air, which is helping the airships actually the landing and to the takeoff. And the other question actually is a very good question when you're asking about the hacking the system. This is actually a very big challenge in any kind of autopilot systems. And there are a lot of different kind of protocols for saving to saving the airship from the hack. And one of these, for example, ways which right now we are just working on it, is that we trying to making the ground control station not only on the ground, so on board as well. So we have two different kind of servers, which they are absolutely async server. They are synchronized server. So if any kind of situations happen in the ground control station, the ground control station will be hacked or get out of access, or any kind of problem such a problems, then we just try to disconnect the ground control station to the airships, and the airships starting to using the onboard systems, which is totally isolated systems, which is totally not connected to the Wi-Fi, and all of these missions and all of the programs, all of the missions, all of the data will be duplicated and saved exactly inside the airships. So in any case, in any kind of situations when the ground control station disconnected, so airships absolutely can handle the pass, or can just follow the pass, can all of this information which from the ground control station go to the airships, we are isolated there, and they are not connecting to the Wi-Fi to going to lose or going to have any kind of problem. So, and about the sensor failure, this is also very good questions. When the sensors, for example, getting fail, or for example, they stop to, for example, work or not act or not returning the correct informations. So the one of the things which is mostly, and also they are implementing right now in the drones systems, that they are trying to landing in the very specific zone, which is very accurate, and they are defined before flying. So there are the stations we are trying to set up exactly inside our applications. So if the very critical sensors try to fail, or any kind of unpredictable situations going to happen inside the airships, for sure we are not only going to use one sensor, we are going to use multiple sensors for sure. So if one sensor is just getting failed, so we are activating the second sensors. But if the sensors mostly because of any kind of reason getting failed, we are just going to land the airship by AI exactly in that station which we have defined inside the application. And what is the advantages of using the AI in autopilot instead of the robots? It is actually very quite good questions. The advantages of using the AI, as I explained already inside the application, instead of robots, somehow inside even that robots, probably you can see some AI. So even inside that robots, if you're, I don't know exactly which kind of robots you're talking about, but even inside the most of the, no, I can claim right now most of the new generation of the drones using the AI for the different kind of aspects. So for the computer visions, for detecting, for landing, for takeoff, for I don't know, a different kind of aspect they are using the AI. So I can say that right now for any kind of autonomous vehicles, like robots, like drones, like airships, or other vehicles which is not aircrafts, there is AI. So they must be AI, because without AI it's a very high risk, absolutely not safe to launching the vehicle. Otherwise you must just control it by some manual control, which is absolutely not functional, I can say, if you are going to manual the airships like by controller, or just trying to manually handle the moving the airships. What allow the airships actually to withstand the strong in the strong winds? As I mentioned it already also in my speech, the wind is a very, I can say, a big challenge right now in the airships, and it was and still, and no one cannot claim with AI 100% accuracy you can fix this problem. I mean the wind intensity. So this is quite challenging for now. And the algorithm can every day updates different kind of methods, different kind of papers published fixing this winds problem by the AI. And this is why we are working right now on it. We cannot claim that 100% accuracy. We can all come to the point that fixing this problem, but that algorithm which I've already mentioned, reinforcement, and the huge amount of the data which we are working on it. We have a data scientist working on it. We are modifying the data. We are collecting this data, wind speed or other data from the simulator. We are working on it right now. So, but we are not going to claim that 100% it is safe by the wind. So the wind, for example, turbulence, for example, we are going to apply an algorithm to decrease somehow the error, or for example any kind of problems which is going to happen for the airship in the wind turbulence. And but the AI has a very positive impact. We have tested that also for the drones. Testing this, we are going to decrease this error accuracy which wind can impact on it. So from the end, please, what is the difference between the future airship and the already existing airships? This is also the very good questions. What is the difference between the future airship and the current airship? Most of the current airships, they are not using exactly AI. This is why we just came to this webinar to discuss about this. But the modern airships going to this direction, to using all of the pipeline ecosystems, bring it to the AI. So they are not going to manually with joysticks control it, or you're not going to only put the pilot inside the airships. Why? I'm just saying it's actually quite a good question. I can just mention one important thing right now about the monitoring, for example. Suppose you want to monitor, yes, some inaccessible place or zone, and you're supposed to monitoring this area by the couple of hours or even 1 month. So you're not able to put exactly the pilot to using and send it to this area for monitoring for you, or scanning the area even. So what you must do, just you must make autopilot system to trying to sending there and try to activate the camera, try to scan the area, try to monitor the area, and try to reduce your cost somehow. So this is why the current traditions airships are not able to do it. This is why. Or even if probably you see that some airship without any kind of pilot, they are flying, but they are mostly working by the, so like I can say like a joysticks, or they are under the manual control. So, but if for example you want to control it truly by the ground control station, in this case you must be using some AI and autopilot system to send the airship in the specific zone, try to activate the camera, scan the area, and monitor the area. So this is actually the most important difference. This is why we are coming to digitalize exactly the ecosystem of the airships, to not only using the traditions algorithm and tradition method, but try to bringing the new modern AI, which is currently all these methods and algorithms which I have already mentioned, using in the drones, using in the Tesla, for example, or any kind of auto vehicles. They are all of them going to this to these directions, to bringing everything to reduce the cost, make it ready for the business. Thank you so much.
Компания AERONOVA создает линейку аппаратов разных классов, от легких беспилотных платформ до тяжелых дирижаблей для сложной логистики, на примере которых мы продемонстрируем их возможности и эффективность в современном мире. В линейку аппаратов будет входить несколько прототипов. Это NOVA 01 и Аэролет 01. Эти аппараты создавались специально для того, чтобы на них опробовать и применить в действии все те современные решения, которые компания планирует применять в своих будущих моделях. Рад вам представить нашего первенца. Это дирижабль NOVA 01. Фактически это динамическая копия нашей следующей модели дирижабля NOVA 2. На нем мы отрабатываем управление, систему автопилота, сбор данных. В будущем его модификация, уже доработанная, может быть как отдельный продукт, будь то мониторинг или реклама. Его размер составляет 130 кубических метров, длина 17 метров. Он может брать с собой на борт 20 килограмм полезной нагрузки, будь то какое-либо оборудование, либо любой перевозимый груз. Также будущие модификации этого аппарата могут стать отдельным коммерческим продуктом, где этот аппарат может стать платформой для рекламы, либо средством для мониторинга и наблюдения. Аэролет 01 – это наша гибридная версия с улучшенными аэродинамическими характеристиками. Это экспериментальная модель, на которой мы также отрабатываем новые решения, нестандартные для дирижаблей, но которые, возможно, будут применяться в следующих моделях. В нем помимо аэростатической подъемной силы будет работать еще и аэродинамика, которая улучшает его показатели в некоторых задачах, в которых могут быть применены дирижабли. Его объем практически 190 кубических метров, длина составляет 19 метров и грузоподъемность, которую он может брать с собой на борт, около 50 килограмм. Также в линейку аппарата будет входить дирижабль NOVA 2. Это дирижабль объемом 2000 кубических метров и способный перевозить 500 килограмм на 500 километров. Его пассажирская версия будет рассчитана на 6 человек, включая пилота. Следующий за ним дирижабль NOVA 8 объемом 8000 кубических метров. Этот аппарат уже способен будет перевозить 19 пассажиров, либо 4 тонны на 3000 километров. А завершает линейку аппаратов дирижабль NOVA 35. Это дирижабль уже совсем иного класса, который имеет жесткий корпус. Это будет первый и самый маленький аппарат с жестким корпусом, который компания планирует выпускать в будущем. Данный аппарат способен будет поднимать минимум 15 тонн и перевозить груз на 1000 километров. Данная линейка аппаратов будет закрывать достаточно большой объем потребностей, который сформировался сейчас на рынке логистики и грузоперевозок. А наш следующий шаг – это дирижабль NOVA 2, который способен перевозить 6 пассажиров, либо 500 килограмм на 500 километров. Всем спасибо, кто смотрел это видео. Друзья, оставайтесь с нами. Впереди будут новые ролики и выпуски того, как мы возрождаем дирижаблестроение. И увидимся в следующих роликах.